So I think I'm gonna start now. If anyone has any, so I think we're gonna start with homework. Does anyone have any questions about either unmute your mic or raise your hand? If you guys don't understand anything, here's the answers pulled up. And then you can private message me or you can raise your hand, or unmute your mic. And then I'm gonna pull up the homework in a second, but these are the answers. So if you want to go double check the work that you did, yeah. Does anyone have any questions?
So, would it count if there's if we did our answers in exponent form?
Yeah, that's fine, because the most of it was doing exponent rules. And I'll explain that in exponent form in a second, when I pull up the homework, but these are just like the numerical answers if anyone has any questions. Yes, I can explain number 8. Also, number 8, if you wrote 7 or greater than or equal to 7, either of them work. Both of them are right answers. But here, I'm gonna pull up the homework. Just give me a second. Okay.
Oh, public.
So let me take the PDF and open it. So here. Okay, so question 8 was meant to be a bit of a harder question, so it's okay if you didn't get this because we didn't explain this as well in class. But for question 8, I think that what I wanted you guys to do was kind of like test values of 2 to the power. Like I'm sure we know the small ones, right? Like 2 squared equals 2, 2 cubed equals 8, etc. And you guys are allowed to use a calculator for these because some of these numbers get big. But if you're asking for what integer number is a, it's 2 to the a greater than or equal to 100. So then we can kind of test 2 to the powers, right? Like we know we can go from 2 cubed equals 8. And then that times 2 would just be 2 to the 4th, which equals 16. 2 to the 5th equals 32. 2 to the 6th equals 64. And then we have 2 to the 7th equals 128. Now 128 is the smallest number that's greater than 100, right? For 2 to the power, because we know 2 to the 6 equals 64, which is less than 100. So 2 to the 7th is 128, which is just greater than 100, which is why the number A is 7, or any number is greater than 7. Does that make sense? If you guys did get that.
Yeah.
Okay.
I have a something to say. So I wasn't here for the classes before, so I don't know what's going on so much.
Yeah, that's okay. Last class, I recorded the class, and if you open Google Classroom, you're gonna see this, right? And then the recording for last class and the slideshows are all right over here. So feel free to look over that from last class. And last class was exponents, which is okay. So then you can kind of look over the homework and stuff from last class. What happened last class isn't super related to today, so you'll be okay. But when you have time, look over like last class, which is the first class, and the slides and the recording, and then feel free to email me or like message me on Google Classroom if you have any questions. Is that good?
Yes, and also do I have to do the homework, or should I just review the homework?
You should review the homework. It's okay if you don't do it. That's totally fine since you weren't here. But just review it and yeah. Does anyone have any other questions either related? Yeah, no problem. Either related to exponents or just this class in general? Okay. Notice that we're good. I'm gonna quickly, very, very quickly, just go over the problems from last time so that I can quickly explain for anyone maybe who doesn't understand something. So the answer to number 1 is 1 because any number to the power of 0 is 1. So I can put any number here in the base and that'd be 1. And then for this one, since it's 8,305 to the power of 1, that's just itself. So that's just 8,305. This one in exponent form, it's 4 to the 5th power. because we can add the exponents since we're multiplying two numbers with the same base. That just equals 1024. For problem 4, you can also do the same thing. You can add the exponents, so that'd be 6 to the 6 cubed, which is just 216. And then this one, you can add the exponents inside, so you get 2 to the 5 and then squared. And then 2 to the 5 squared is just 2 to the 10th, which equals 1024 as well. So just make sure that you don't like drop the square or something if you're computing inside. True or false? This one's true. I think this one kind of tripped a bunch of people up, which is okay. It's totally fine. This can be kind of tricky at first. This is true because if you take the exponents, right, like if you raise 2 cubed, then squared, we know that this is just 2 to the 3 times 2, which equals 2 to the 6. And on the other side, it's the same thing. 2 squared, then cubed is just 2 to the 2 times 3, which also equals 2 to the 6. So 64 equals 64, and that's how you get the answer. Question 7, the answer was 630 because you can calculate here. It's just 5 squared and then squared, which is 5 to the 2 times 2, 5 to the 4th, and then plus 5, which is 625 plus 5. And then we just went over 8. So that's the answers and a very brief explanation for all the problems. If any of you guys still don't understand, feel free to message me on Google Classroom or message me here. So, but that's like the quick overview. You guys did a really good job on that. Most of you guys had, I think almost like all of you guys had majority right answers. There are sometimes maybe like a computation, like multiplication error or something like that. But I think you guys understood the concept really well, which is really good. So you guys did a great job. So now that we're done talking about last time's homework, we can move on to today's topic, which is number theory. And the number theory that we're going to cover today is like divisibility, prime numbers and prime factorizations, greatest common denominator, and least common, greatest common divisor. So we can start off with divisibility. What is divisibility? Well, you can say that this is, again, the top sentence. We're going to use variables to describe this. If you don't know variables, that's totally fine. We'll discuss the example, so hopefully that'll make more sense. So a number A is divisible by another number B if there's no remainder when you divide A by B. So the result of A divided by B is a whole number. So let's look at an example of this. We can say that like 24 is divisible by 6, right? Because 24 divided by 6 is equal to 4, and there's no remainder. Like it divides evenly in. And then you can also say like 24 is not divisible by 10 because you cannot divide 24 by 10 without having a remainder. So this is just a quick problem. I'm sure you guys can solve it really quickly. Do you guys think 35 is divisible by 7? Raise your hand if you say yes, and don't raise your hand if you think no. Okay, yes, good. That's a quick question. It is because we know that 35 divided by 7 equals 5 based off of multiplication. So that was great. You guys did a good job with that one. Does anyone have any questions about either the definition of divisibility or any of these examples? Okay. Again, if you have any questions about this and you're just taking notes, feel free to message me. But that's the very basic definition of divisibility. So now we're going to move on to divisibility rules, right? Like sometimes when we have really big numbers, it can be hard to tell if it's divisible by certain numbers. So these rules are put in place so that you can quickly see what number is divisible by what. So for example, we can start off with divisible by 2. Any even number is divisible by 2, and all even numbers end with 0, 2, 4, 6, and 8. So if the ones place of any number has either 0, 2, 4, 6, or 8, or if it's an even number, then we know it's divisible by 2. Like for example, we know that 20 is divisible by 2 because 20 is an even number, and 20 ends in 0. So that must mean that it's divisible by 2. We know that 21 is not divisible by 2 because it's an odd number and it ends with 1, and 1 is not one of the numbers on the screen. So that's the divisibility for 2. Now, the divisibility of 3 is to make sure that the sum of the digits of the number are divisible by 3. So what does that mean? For example, we can see the number 18. The sum of its digits is 1 plus 8, right? The 10th digit is 1, the 1 digit is 8. 1 plus 8 is 9, and 9 is a multiple of 3, right? We know that 9 is 3 times 3. And since the sum of its digits are divisible by 3, then that number must be divisible by 3. And then divisible by 5 is if it ends with like 0 or 5. Like 10 is divisible by 5 because it ends with 0. 15 divisible by 5 ends with 5. But like 17 is not divisible by 5. So 5's rule, relatively easier on that end. 6, I wouldn't say this is divisibility rule, but we know that 6 equals 2 times 3. So something is divisible by 6 if it's divisible by both 2 and divisible by 3. So it has to be an even number and its digits add up to some multiple of 3. So that's not really the divisibility rule, but it's good to know. And you can do this with many different factors. Then you have 9. 9 is a really cool one. 9, just like 3, is that a number is divisible by 9 if the sum of its digits is also divisible by 9. Like, for example, we know that 81 divides 9 because 8 plus 1 equals 9, and 9 is divisible by 9. But like 73 is not divisible by 9 because 7 plus 3 equals 10. 10 is not a divisor of 9. So that's kind of how you tell with 9. If you guys are taking notes, do you guys want another minute to take notes, or are we good? And does anyone have any questions about these? Like divisibility? No questions?
No.
Good.
No.
Evelyn? Huang? Do you have a question, or did you just want to answer the practice problem?
No. Well,
Huh?
Can I ask the question?
Yeah.
Does 4 have any specific divisibility rules, or are these all of the divisibility rules?
There are more divisibility rules, but I think these are the ones that we're going to talk about. If you want to know 4's divisibility rule, any number is divisible by 4 if its last 2 digits are divisible by 4. So like if we have a 3-digit number, right? And then we have like some number and then 16, some number and then 04. That number is divisible by 4 because the last 2 digits are a multiple of 4. And then there's also one for 8 and 11. And I can put that in like later if you guys have like want extensions. These are some of the simpler ones and taught earlier on, but there are more divisibility rules out there. That's a good question. Sashi?
Yeah, I can answer the practice problem.
Okay, give me a second. That's really good. I'm gonna just go through everyone else to see if they have any questions. I'm gonna go in order. Your name is Axjung on Zoom, but I don't know. I don't think that's your.
It's so I don't know how to change it.
It's okay. It's okay. Don't worry.
So I just know how to. I was gonna say the answer to the problem.
Okay, perfect. I'm gonna just see. Does anyone else have any questions about these divisibility rules on the page? Kanisha, do you have a question?
Is there a divisibility rule for 7?
7, I don't believe there's a divisibility rule. 7's a little special in that case. Or there's no common.
Okay.
Ritesh? you have
With the problem?
I'm gonna let first, does anyone else have any other questions? Okay, Julia.
Does 8 have a divisibility rule?
8 also has a divisibility rule. But it's a little more complicated. 8's divisibility rule is that the last 3 digits of the number must be divisible by 8. So it's kind of weird. And like sometimes if you have like a big number, you just know that you only have to check the last 3 digits. And if those 3 digits are divisible by 8, then that whole number is divisible by 8. Which in this class, we're going to work with some smaller numbers, like maybe 2 digits and occasionally 3 digits. So that divisibility rule isn't super helpful, I guess. Makes sense? Okay, Joanna, do you have a question or are you answering?
Yeah, I have a question. So does every single number, are the numbers only from like 1 through 10 only have divisible rules, or maybe 11? Or can like any number have a divisibility rule?
Well, some bigger numbers have divisibility rules, like 25 has divisibility rules, and like 100 has divisibility rules, right? But typically when we're talking about divisibility rules, we like to work with these smaller numbers because these are the more like common numbers. Because when you're looking at a big number, there's a really good chance they're going to be able to be divided by numbers like 2 or 5 or 3, right? Because these small numbers can be like they're like factors of a lot of big numbers. But yeah, there are big numbers with divisibility rules, but they aren't really as useful. Like we can see that 100, any number that ends with 2 zeros is divisible by 100, right? But we're not going to be working with like huge numbers, at least in this class. So not as useful in this case.
Okay.
Okay. Any other questions about the divisibility rules?
There's like
Like
70. Nothing.
Okay. In that case, I'm going to yeah. Okay, Sasha, you're the first person to raise your hand. Do you want to answer the problem?
Yeah, sure. So for to check that if 126 is divisible by 3, we add up all the digits. 1 plus 2 plus 6 equals 9, and 9 is divisible by 3. So 126 is divisible by 3. For the number 6, so we already know that 126 is divisible by 3. And since we know that 126 is an even number, we know that it's also divisible by 2. So that means that it could be divisible by 6 as well. And finally, for it to be divisible by 9, we add up all the digits again and we get 9, and 9 is divisible by 9. So we know that it's divisible by 9. So it's divisible by all 3 numbers.
Okay, that's a perfect answer. Really good job. Good. Does anyone have any questions regarding that practice problem? Or no? I'm gonna assume not. If anyone has any questions, again, feel free to message me. But if that is the case, I'm going to move on to the next page when I can, because page is weird. Okay, so now we've kind of covered divisibility really briefly. So then we have prime numbers. So what is a prime number? Well, strictly the strict definition is a prime number is a number with exactly 2 factors, right? Only 2 numbers divide it, or 2 numbers are divisible. So the factors also have to be 1 and itself. There's no other factors or numbers that divide it. So then the opposite of a prime number, you could say, is a composite number. A composite number is a number that has more than 2 factors, right? Many numbers can divide into it. So we can say that, like, if we think about this, 7 is a prime factor, right? Only 1 and 7 are its factors. No other numbers divide 7. But 8 is a composite number because we know that 8 is divisible by 1 2, 4, and 8. That's 4 factors. So you can say this. We know that we can start from the number 2, right? 2 is a prime number because 1 and 2 divide itself. But then all other even numbers aren't prime because all other even numbers are divisible by 2. Okay, I'm assuming that you guys are raising your hand to answer the question, which is good. Just quickly before that, does anyone have any questions about either like what is a prime or what is a composite number? Evelyn, do you have a question? Or are you answering the practice problem?
Well, at first I was gonna answer the problem, but I actually have a question.
You want to answer?
Is 0 prime?
0 is a weird case. Technically, all numbers divide 0, right? Because 9 times 0 is 0. 8 times 0 is also 0. So I think the general consensus is that 0 isn't prime. But that's a really good question. 0 is kind of a weird case, but since all numbers technically divide 0, it's not prime.
Thank you.
Any other questions before we go to answer question? No more questions? Okay, I'm gonna assume no more questions. If you have any questions, feel free to either message in chat or just unmute yourself. X Jung, what's your real name? Because I don't want to keep calling you that. Do you want to answer the question as well?
Yeah, my name's Zoe.
Okay.
I don't think so because like prime numbers are only like have 2 factors and 1 has only 1 factor.
The really good answer. Yeah, that was a trick question. 1 is a weird number. Some people like in the beginning, it's like weird. Some people are like, oh, it's prime. Some people say, oh, it's not prime. But based off of the definition of prime, which says a prime number is a number with exactly 2 factors. It has to have 2 different numbers that divide itself. Therefore, 1 is not prime because it only has 1 factor. Only 1 divides itself. No other number divides 1. Does that make sense? Does anyone have any questions? Kanisha, do you have a question?
No, I wanted to answer the question.
Okay. Anyone? Priya, do you have a question?
No.
Okay. Joanna, do you have a question?
Yeah, it's not really a question, but is it also concerned as a special number?
Yeah. 1 is a really special number. In this class, we'll say that 1 isn't a prime number, and most people say 1 isn't a prime number, but some people do make cases saying that 1 is. So it's special, but in this case, we're gonna say 1 is not.
Okay.
Evelyn?
Can you have a prime? Actually, never mind.
Okay. Yeah, if you guys have any other questions, feel free to either private message me in chat or raise your hand. But yeah, you guys ask really good questions, and I like that you guys are participating a lot, which is really good. So that's prime numbers. Now we're going to talk about prime factorization. Every single number has a prime factorization. And a prime factorization is just writing a number as a product of its prime numbers. So just for context, because sometimes when we work with numbers, some big numbers, right, it's hard to know what's prime. I think the primes that we're going to work with most in this course are going to be 2, 3, 5, 7, 11, 13, 17, 19, and those are the primes up to 20. If you want to memorize more, definitely feel free to. I would highly encourage, if you want to do more harder math in the future, or if you find this interesting, to maybe memorize primes up to about 100. I think that's a really good stopping point if you want to. You don't have to do this now either, but it's really good when you're factorizing. Yeah, Evelyn, do you have a question?
When you're writing out a prime factorization of a number, is there a specific order you have to put it in least to greatest, in your example?
Technically, there is no order, but really good mathematicians will order it from least to greatest because it's organized and it'll help people who are looking at their math to find easier, like if you made a mistake, it'd be easier to check because it's in least to greatest. So I encourage you guys to put it in least to greatest, but you don't technically have to. But it's good to get in the habit. Okay?
Okay, thank you.
So for an example of a prime factorization, right? If we take the number 36, we can do 36 equals 6 times 6, right? Because we can pull out these factors. And 6 equals 2 times 3. Other 6 also equals 2 times 3. There's 2 2's and 2 3's, so that's just 2 squared times 3 squared. So that's kind of where the exponents from last class kind of come in, but the numbers that we're going to work with are small enough that it should be okay, even if you aren't super solid on exponents. My favorite way of finding prime factorizations, especially when we have really big numbers, is kind of to use these trees. I put like images of these below. So there's really no right way to write a tree and a wrong way. You just kind of pull out one factor and then take its primes, and then pull out another factor and then take its primes. So for like the tree on the left, 72, we have 9 times 8 is 72. And 9 equals 3 times 3, 3 are primed. 8 equals 2 times 4, 2 is prime. 4 equals 2 times 2. It's really good to get in the habit of like either, especially if you're working with smaller numbers, circle the prime so you don't go and overfactor it later, and then just leave with positive consensus. But how I like to do them is that when you have a number, I like the tree on the right better, but this is just personal preference. Like if you have 60, then we have 2 and then 30, right? We know 2 is a prime, and we can see that 60 is even, so it's easy to just pull out 2. And 30, we also know is even, so we can pull out 2, 15, 3, 5. That's how I like to do them. I like to pull out first to see the smaller numbers, right? Like, is it divisible by 2? That's pretty easy to check. Just know that if it's even, divisible by 2. So then if I were to write out a tree or prime factorization, the first thing that I tend to pull out is the 2, because dividing by 2, splitting it in half, it's not as difficult, and it's like not like it's harder to make a mistake. So then divide by 2 as many times as you can, count those number 2's, and then check 3, right? It's pretty easy to see if a number divides 3, because you can just add up its digits, and if it's divisible by 3, it's divisible by 3. And then same thing with 5. So then I go with smaller numbers first, and numbers that I know are prime, so that it just makes it easier to write out the prime factorization. But you don't have to do it that way. That's just the way that I do it, and I find it most useful. Does anyone have any questions about prime factorizations? Zoe?
So it's not really a question, but like, here's the thing to make it a little bit easier. So if you have multiple of the same number circled, the amount of times you have it is like, you have 2 3's, it's 3 to the second power.
Yeah, exactly. That's why it's good to circulate numbers, because then you can count up the number of those numbers, and then that's just your exponent in the prime factorization. So the prime factorization form is this like exponent form. But yeah, if you have any questions about this, feel free to ask. I think I'm gonna move on to the next slide, unless anyone has any burning questions. So I'm just gonna quickly go over these. Just raise your hand whenever you have an answer, and I'll call on people who like haven't been called on so far, because I'm keeping track of who has. And then if everyone's been called on, then we'll move on. But if you have an answer to any of these questions, feel free to raise your hand, and I can just call on you then. But explain your answer. And also, I know one of these problems is already done on the last slide, but that's fine. We can just go over it again. But yeah, explain your answers. Some of these use divisibility rules. Clearly there's a 7, so you might just have to divide. Evelyn, do you want to go first?
Do we each answer one problem?
Yeah, find one of these problems and then answer it. It can be any problem. You don't have to go in order.
Okay, then can I answer number 2 instead of number 1?
Yeah.
So I made a factor tree, and I split 84 into 7 and 12, and I split 12 into 3 and 4, and I split 4 into 2 and 2. So you have 2 squared times 3 times 7.
Okay, perfect. That's really good. That's the correct answer as well. So good job. Zoe, you spoke once, and Sasha, you spoke once. Keep your hands raised, or like I can just keep track of that actually. But if you want to, keep your hands raised just in case that other people haven't answered. Aisha, do you want to answer a question?
Yeah, sure. So, can I answer number 4?
Yeah, absolutely.
Okay, so the divisibility rule for number 9 is the sum of the digits, and 1 plus 4 plus 7 equals wait 12, and then 12 you can't divide divide it by 9, so it's not divisible by 9.
Okay, perfect. That's a really good answer. Good job. Kanisha, do you want to answer a question?
Sure. I don't think 132 is not divisible by 3. Wait, it isn't because 3. Wait, no, it is. Sorry. Because 3 plus 2 is 5, and then 5 plus 1 is 6, and 6 is divisible by 3.
Okay, perfect. Good answer. Smithmika?
Hi. So for the second one, 175 is divisible by 5 because it ends in 5.
Okay, perfect. That's a really quick one. Good job. Ritesh, do you want to answer the question?
321 isn't divisible by 7.
Okay, good. And yeah, there's no divisibility rule for that because 7's kind of weird. Julia, do you want to answer a question?
The first one, 6. I split into 2 and 15. 2 is prime. 15 I split into 3 and 5.
Okay. Good job. Yeah, so 60 is split in 2 and 30, 30 is split into 2 and 15, and then 15 is 65. Good. Valerie, do you want to answer a question? Valerie, you're muted, by the way.
246 is divisible by 6 because 24 divided by 6 equals 4, and then 6 divided by 6 equals 1. So then you get 41.
Okay, good. So all the true or false questions are answered. Now we only have 105 and 20. So E, do you want to answer a question?
Wait, I forgot. Wait, which question isn't answered yet?
The third one. So factor 105 into primes and then factor 120 into primes. Do you want to answer one, or it's okay if you don't?
So the 105 into primes, it could be.
You can walk us
I
through
want to
this.
do 120.
Okay, you can do 120.
62 and 60.
Good. And then?
And wait, what do I do now?
Okay, so you have 2 and 60, right?
Yeah.
What is 60 divisible by? What number?
60 is divisible by 2 and 30.
Okay, good. Then we go from 30.
And then 30, 2 and 15.
And then from 15?
3 and 5.
Perfect. So now we have all of them are prime numbers, right? And there you go. That's your factorization. You have.
And my name actually is an E.
What's your name?
Jessica.
Okay, perfect. I'm just gonna write that down so that I don't forget.
Because I don't know how to change it.
That's okay. I know Zoom is kind of weird sometimes, so it's okay if you don't know how to change it. Priya, do you want to answer how to factor 105?
Yeah.
Okay. You do.
It's kind of hard.
Okay, let's go through divisibility rules. We see it ends with 5, right?
Yeah.
So what number do you think is divisible by 5?
21.
It is divisible by 21, and it's divisible by 5, right?
Yeah.
Okay, so then we have 5 we know is a prime number. Then for 21, what is 21 divisible by?
3 and 7.
Perfect. So we have 5, 3, and 7. These are all prime numbers, right?
Yeah.
Yeah, so then the prime factorization of 105 is just 3 times 5 times 7. Does that make sense?
Yeah.
Okay, perfect. Does anyone have any questions about any of these questions? Or do they all make sense? Okay, I'm gonna assume these all make sense. You guys did a really good job of answering these questions. If you guys have any other like doubts or if you don't understand something, feel free to let me know. Okay, so now we're just gonna move on to GCD and LCM quickly. I'm gonna go through this section a bit quickly. There are some practice problems on these slides that you can practice, and the answers are also on the slide. So I'm gonna quickly skip over the answers. But GCD stands for greatest common divisor. It can also be written as GCF, which is greatest common factor. So both of those are interchangeable. The GCD of two numbers is the largest whole number that is a divisor of those two numbers. So for example, GCD of 12 and 18 is 6, right? Because 12 equals 2 times 6, 18 equals 3 times 6. The biggest number that divides both of them, or is a factor of both of them, is 6. So if you have two really big numbers, well, how do you find the GCD? The easiest way to find the GCD is to start off by prime factorizing both numbers. And then, okay, I don't know why that's this command. I think my computer made a typo. But you multiply any of the numbers that you have in common. So in the case of 12 and 18, right, we can see that 12 equals 2 times 2 times 3. 18 equals 2 times 3 times 3. They both have a 2, and they both have 1, 3. So then we could multiply these, and 2 times 3 equals 6. And that's their GCD. Okay, Evelyn, question? Or are you answering one?
I have a different way.
Yeah?
Well, it's called the cake method, but it's hard to explain if you don't see it visually. Should I write
Okay. You can write it on paper or something if you want.
or should I annotate?
You can also annotate. Yeah. Feel free to.
So basically, you draw like an L, and then if you take like 12 and 18, you can just find any number that's divisible between both of them. Like, let's say you put 2. 12 divided by 2 is equal to 6. You put 6 under 12. And then 18 divided by 2 is equal to 9. So you put 9 under 2. And then 6 and 9 are also both divisible by 3. So you put another L. And then you put a 3 over here. And then you do 6 divided by 3 is equal to 2. 9 divided by 3 is equal to 3. And then since 2 and 3 are prime, you multiply the two numbers on the side going vertical, which is 2 and 3, and then you get 6.
Yeah, that's a really good method. I think that's actually really smart. Yeah, so you can also do it that way. There are many ways to find prime factorization. Find GCD. But both ways you have to factorize. So the most important thing is to kind of factorize the numbers. But yeah, that was a really good method. Sashi, do you have a question? Or do you want to answer the question? Okay, I'm assuming that she's like, oh.
Yeah, I have the answer to the practice question.
Okay, does anyone have any other questions? Or no? Okay, Sashi, do you want to answer the practice question?
Yeah, I'll answer it. Okay, so for 36, we have to do the prime factorization. So 36 can be divided into 6 times 6, and then that would be 2 times 3 times 2 times 3. And then for 42, it's 7 times 6, and then you prime factor 6, which is 2 times 3. So it's 7 times 2 times 3. And then the common numbers here are 2 and 3. So you multiply 2 with 3 and you get 6. So the GCD of 36 and 42 is 6.
Perfect. Okay, that was a great answer. Does anyone have any questions about the problem or GCDs? Okay, if you don't have any questions, lower your hands because I don't know if you have questions or not. Evelyn, do you have a question or like anything to say?
I have a question. So, like, let's say, like, you're trying, like, someone gives you a problem for some reason, and they want you to find the GCD of, like, 27 and 5. 5 is prime, so what would you put?
Well, then the answer would be 1, right? Because every number is divisible by 1. If they don't have any numbers in common, then the only number that they have is 1.
Oh, that makes sense. Thank you.
Yep. Zoe, do you have a question? Or no?
It's not really a question, but in my class this week for math, we actually did that, and I have like this helping sheet, and it also has like prime factorization for it.
Okay, that's good. Yeah, see, that's really cool. Yeah, for GCD, I think the most important part is factorizing, prime factorizing. No matter what method you use, you still have to kind of divide numbers. So that's really cool. So I'm gonna skip over these practice problems because we have 15 minutes left. But if you want to do them, feel free to do them. These slides will be posted again, so you can look through these at any time. The answers are also on the slides. So, yeah. But if you have any questions about them, you can always go over them later. So after GCD is LCM. LCM is least, oh my god. I don't know why this still says GCD. I remember changing it earlier. Sorry, anyways. LCM is least common multiple. So the LCM of two numbers is the smallest whole number that is divisible by both of these numbers. So if we look at an example, right? LCM of 4 and 6 is equal to 12. Because we know that 4 times 3 is 12, 6 times 2 is 12. There are no numbers smaller than 12 that are divisible by both 4 and 6. So, like, it's kind of interesting because you might ask, how do you find the least common multiple? Well, I'm going to give you two ways. First of all, if the two numbers don't share any common factors, right? If their GCD, which we talked about earlier, is 1, like they're two prime numbers, like for example, 3 and 5, or 27 and 25. These numbers don't share any like factors in common, right? Their GCD, greatest common divisor, is 1. Well, then the easiest way to find the LCM is multiplying them, because that's the smallest number that divides both of them. But if you have numbers like 4 and 6, which they share a GCD, right? Their GCD is 2, their GCD is not 1, so they share a factor. Then you want to prime factorize both of these numbers, and then take the highest power for any of the numbers in their prime factorization, and then multiply them. So what do I mean by that? Like, we can look at 4 is 2 squared, and then 6 is 2 times 3. Well, they both share a 2. So the highest power of 2 that there is in both these numbers is 2 squared. So we keep the 2 squared. Then we can see that 4 doesn't have a 3, but 6 has a 3 to the 1 power. So then we keep the 3 as well. So then we have 2 squared times 3, 4 times 3, how we end up with 12. Priya, do you have a question? Or do you want to answer the question?
I have a question. So, it's kind of like a statement, but it's like,
That's
is
okay.
it like, is like GCD, like what the two numbers in the parentheses are like this divisible by, and LCM is like the two numbers in the parentheses, like the multiplication, like is
Something
it
like that. Yeah, it's pretty similar. So GCD, yeah, GCD for the two numbers, the GCD of both numbers, like, that number has to be a factor of the two numbers in the parentheses, right? And the LCM, the final number, has to be a multiple of both of the numbers in the parentheses.
so it's basically like factor and multiple?
Something like that, but it's a little bit more complicated than that, but that's a good way to break it down. Yeah.
Okay.
Okay. Evelyn, question?
Do you know how I said something about another method called the cake method earlier?
Yeah.
It also works for LCM.
Mhm.
But it a little bit differently. So let's say you took 4 and 6.
Mhm.
And you put 2 over here, you get 2 and 3. To find the LCM instead of GCF, you multiply together 2, 2, 2 and 3. I'm trying to circle that. And
It's
then,
okay. I'm good. Yeah.
and then that equals 2 times 3 equals 6, and then 6 times 2 equals 12.
Yeah.
So
See,
it
that's
also
a really
works
good.
for LCM.
Mhm. That's also a really good way. Yeah. So that is really good. Just do whichever way you like, because different people have different ways of solving things, and if that's the way that solves faster, that's really good. Yeah, thank you. Priya, do you have another question?
No.
Okay. Sashi, do you have another question?
No, I was gonna answer the practice.
Okay. Does anyone have any other questions regarding LCM? At least comment. So, Samantha, do you have a question or do you want to answer the question?
I want to answer the practice problem.
Okay, it's okay. Sashi, you already spoke once, so Samantha, do you want to answer the question?
Yeah. So the LCM of 8 and 10 is 40, because when you're listing the multiples of 8, you get 8, 16, 24, 32, 40, and so on. And when listing the multiples of 10, you get 10, 20, 30, and 40. And 40 is the smallest number that overlaps between the two. So 40 is the LCM of 8 and 10.
Okay, perfect. That's a really great answer. Thank you. Does anyone have any questions about that question or LCM? And if you do, just unmute yourself, because, yeah. But I think.
I can explain it in the way that you showed it. If
Do
you
you
would
want to
like.
explain it?
Yeah, I can explain it in the way that you told us to do it.
Sure.
So for 8, when we prime factorize it, we have 2 times 2 times 2. So that's 2 to the power of 3. And for the number 10, we have 2 times 5. So now when we look at 8 and 10, the 2 is common, but in 8 we have a higher power because it's 2 to the power of 3. So we keep that. And then for 10, we also have 5 to the power of 1. And then you do 2 to the power of 3, which is 8, and then 5 to the power of 1 is 5. So 8 times 5 is 40.
Okay, perfect. Yeah, that's the way you can do it through prime factorization. That was really good. Again, I have practice problems, but because we're kind of running low on time, just gonna skip this really quickly. If you want to go back, you feel free to do these problems. They're really great practices. Last thing for today is just how GCD and LCM are connected. So again, top explanation is using variables. Bottom one is an example. If you don't know variables, totally fine. You're not expected to know variables. So if you have two numbers a and b, the GCD of a and b times the LCM of a and b is just a times b. So an example, if we have 6 and 8, the GCD of 6 and 8 times the LCM of 6 and 8, well, the GCD is 2, right? They're both divisible by 2. LCM is 24. These come multiple. 2 times 24 is 48. You know what else 48 is? 48 is also 6 times 8. And then you can also do this with 2 prime, like 3 and 5. GCD of 3 and 5 is 1, right? And then LCM of 3 and 5 is 15. Well, 1 times 15 is 15. 3 times 5 also equals 15. So that's just something cool to know. This is not something that you actually learn till later, but it's really cool to know and cool to think about. Sasha, do you have a question? Or a statement or something?
Oh no, I'm sorry, I forgot to lower my hand.
That's okay, don't worry. Does anyone have any questions about this? Or any statements, anything you want to say? It's okay if you did. Okay, I'm gonna assume not. I was going to do a Kahoot today, but we don't have time. So I can't, but if you guys want, we can either do a Kahoot next class or you can review this stuff with a Kahoot at the beginning of next class. But yeah, we can do a Kahoot next time. For now, this is just a quick summary of what we learned today. So in case you're super lost, these are kind of 5 things that you kind of want to know. Prime factorization breaks numbers into prime. Divisibility rule quickly tests if the numbers are divisible or divides evenly. GCD, greatest number dividing the two numbers, greatest common divisor. LCM, smallest number, both numbers are a factor of or divided into. And then GCD times LCM is the product of the two numbers. So that's just the very quick summary of everything we covered today. Does anyone have any final questions? Feel free to raise your hand. Yep. Anyone have any questions? You can unmute yourself if you want, but if not, I think I'm gonna end class here because I was going to do a Kahoot, but we don't have time, unfortunately. So I'll make more time next time to do a Kahoot. But that's about it I have for today. So yeah, thank you guys. If you guys have any questions, you can either stay behind. But for now, that's all. Bye.
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 Bye. Thank you.
We're good teacher.
Why are all the teachers?
Bye.
Thank you.